Boom! Alright, so welcome to another going through the CSEC AdMath syllabus. In this video, we're going to continue our work on the division, the long division of polynomials. Now, up to this point, we have only worked with polynomials where the divisor was a factor of the dividend. So in other words, you didn't have a remainder. So for example, we would work with something like 36 divided by 9. And we know that the answer is 4 when we do that. Good? And then if we say, let us say for the sake of argument, if we say that 36 is equal to 9 by 4, we know that 9 itself could also factorize as 3 by 3, and then multiply back by the 4. Alright? I just writing that just so that you could get the concepts ticking in your mind. Ticking in your mind, even if at a kind of semi-subconscious level, if you want to put it like that, right? The whole idea that when you factorize something, the first level of factorization, you could also factorize it again. All right, so with that out of the way, let us now deal with the situation where we have a remainder. So we would have worked with this guy, all right, and we would have gotten certain things working with certain factors. So in the same way that when we divide 36 by 9, we expect the answer to be 4. If, let us say, we add 3 to 36, and we divide, so we know that 36 divided by 9 is equal to 4, right? So if you add 3 to 36 and you say 39 divided by 9, you know the answer is 4 with a remainder of 3. This 3 is the 3 extra that you would have added on to 36 to get 39 here. The reason why I'm going through that is because I'm going to now add a certain amount to this polynomial and then divide it by one of the factors that we would have used before, and verify that we will actually get a remainder equal to the amount that we added on in the first place. So, okay, we have x4 plus 2x cubed minus 13x squared minus 14x plus 24. Let me add a random number to that. Let me say 27. Okay? So we know that 24 plus 27 is 51. So from this, we add 27 to this. So we add 27, and the new polynomial we have would be x to the power of 4 plus 2x cubed minus 13x squared minus 14x plus 51. All right, so we have a new polynomial now. Good. Now we're going to divide this by, what did we divide it by the first time? I can't remember which of the two quadratics we divided it by the first time, but at this stage of the game, it really doesn't matter which one we use because the same remainder would appear. All right, so let me just verify. Hold on. Okay, that's the first one. This is the second one. Right, okay, I have it here. So, right, so we had two quadratics. We could choose any one. So I will use, I think, x. Anyway, all right, so we're going to divide this polynomial in blue. We're going to divide, let me just go old school here now. We divide that by x squared plus x minus 12. And we're going to do that and verify that the remainder when we do that is not 51 but 27, because 51 is 27 in addition to the 24 at the end here. Alright, so when we divided this polynomial in black by x squared plus x minus 12, if we do that, we expect to get a remainder of 0 because we know from our previous working that x squared plus x minus 12 is a factor of this long polynomial here. So if we divide this by this, we expect the remainder to be 0. However, by adding 27 to this polynomial, we have now created a situation where we expect with a lot of confidence to get a remainder if we divide this new polynomial here by x squared plus x minus 12. So the next step now is to actually do the long division and verify that in fact we will get a remainder of 27. So let me check it out. Alright, so let me take some space on the side here to do the long division. Alright, so we divide in x4 plus 2x cubed minus 13x squared minus 14x plus 51. And we divide in that by x squared plus x minus 12. Good? So we can rub off everything else because that is the information that we would have used to derive the situation that we now have here before us. So we starting off knowing what the answer will be, and that is one of my methods to demonstrate the concept. We build the question, we build the sum then, and then we take the question that we have constructed and work it as if we're meeting it for the first time and verify that we will actually get the answer that we're expecting to get. Alright? So x squared into x4 is x squared. Now I will go through this a little faster here because you would have already seen the process in previous videos, so I'm not going to spend a whole set of time in this video explaining it. We're just going through it now. This is just reinforcement of what you would have seen in the previous videos. So x squared into x4 is x squared. X squared multiplied by x squared is the same x4 here. Alright? X squared by x is x cubed. X squared by minus 12 is minus 12 x squared. Alright, so you minus in, you got a nice long line there. So we subtracted x4 minus x4 is 0. 2x cubed minus x cubed is 1x cubed. Excuse. Minus 13x squared minus 12x squared minus 13x minus excuse is minus 13x squared plus 12x squared, which will give you minus x squared, and then we bring the minus 14x down from the top because we have three terms here. So we're going again. X squared into x cubed is x. Alright? X by x squared is x cubed, so we minus in. X by x is x squared, and x by minus 12 is minus 12x. So we subtract in here now. X cubed minus x cubed is 0. Minus x cubed minus x cubed minus 1 is minus 2. So minus x cubed, sorry, minus x squared is minus 2 x squared, and minus 14 minus 12 is minus 14 plus 12, which is minus 2. Minus 2x, and then I bring down the 51 from on top. So we're going again. So x squared into a minus 2x squared is minus 2. Right, so maybe you've seen the 27 taking shape, but you'll see it if you're not seeing it yet. So minus 2 by x squared is minus 2x squared. Minus 2 by x is minus 2x. And minus 2 by minus 12 is plus 24. So the same 24 that we would have gotten if we had divided, the same 24 that we would have had from the original polynomial, but we would have added 27 to this to get the 51 here. So now we're minusing, boom, boom, 0, boom, boom, 0 again. 51 minus 24 is, guess how much? 27. That is your remainder. So we could say now that x to the power 4 plus 2x cubed minus 13x squared minus 14x plus 51 divided by x squared plus x minus 12 is equal to x squared plus x minus 2, remainder 27, or you can write it as x squared plus x minus 2 plus 27 over, and it will be 27 over the original divisor, which would be x squared plus x minus 12. Right? Ding, 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 ding. Minus 12. And that is what is going to take place when we do what we do. All right? And that's it. That is it. All right? So you actually see the remainder here in your working. So we're now at the stage where we're not just working with remainders of 0. We're not just working with factors, but we're working solidly now with situations where you're starting off at the outset expecting to get a remainder. So we're now making the shift, we're now making the transition. So in learning the procedure, in learning the concept at the early stage, we work with factors because we wanted to get familiar, we wanted to get comfortable with the whole mechanics of long division. But once you get comfortable with long division in a situation where you don't have a remainder, you now move to another level now where instead of expecting to not have a remainder, you're now actually expecting to get a remainder. And when you don't get a remainder, you say, aha, we do have a remainder here. We have a little special case here. All right? So we're building up now to the remainder theorem and the factor theorem, but we have at least one more video to go before we get to that. And in the next video, we're going to use the next quartic polynomial, the next polynomial of 4 that we would have been working with earlier on, and go through the same process here and verify that we could do the division and get a remainder, and we take it from there going forward. All right, so we're going to continue in the following video. Stay tuned, keep the enthusiasm up. We have plenty of work to do still, but we're going to get the job done.